I am Aditi Rathore. Today I am gonna cover a streaming platform that is Apache Kafka, in which I will cover what is it, benefits and its uses, its architecture, advantages, and its function applications. So, Apache Kafka is an open source distributed streaming platform designed for real time data processing and event driven architecture. It functions as a high throughput, fault tolerant, and scalable messaging system, enabling efficient ingestion, storage, and retrieval of data. Kafka's architecture revolves around three core components: producers, brokers, and consumers. Data is published by producers to topics which are logical channel for data streams. These topics are divided into partitions, enabling parallel processing and scalability. Consumers subscribe to these topics and process the data in real time. Kafka offers strong durability and reliability through data application, and it decouples data procedures for consumers, allowing flexibility and independence in data processing. Its versatility, ecosystem of connectors, and seamless integration with various data sources make it a fundamental tool for building modern data-driven systems and applications. Kafka's applications are decoupling system dependencies, messaging, notifications, streaming processing, real-time data pipelines, processing big data, and the many more. So, one by one, I will explain these uses. Decoupling system dependencies is a fundamental principle in software and system design aimed at reducing tight connections between different components or modules. By doing so, it enhances flexibility, maintainability, and scalability. This decoupling can be achieved in several ways. Firstly, using well-defined interfaces such as APIs ensures that the different parts of a system can interact without needing in-depth knowledge of each other's interval connections. Secondly, the implementation of messaging queues like Apache Kafka and RabbitMQ can decouple systems by allowing them to communicate asynchronously. Thirdly, employing the principles of microservices, the architecture enables the creation of loosely coupled independent services that can be developed, deployed, and scaled independently. Overall, decoupling system dependencies enhances the system reliance, maintainability, and agility, making it a crucial design consideration in modern software engineering. Messaging in a computing context refers to a exchange of data, commands, or notifications between software components, applications, or systems. It serves a crucial mechanism for communication and coordination in distributed and interconnected environments. Messaging systems enable asynchronous communication, allowing components to send and receive messages without the need of both parties to be simultaneously available. This approach enhances scalability, reliability, and decoupling in software architectures. Messaging is essential in various scenarios, including real-time data sharing, event-driven systems, task distribution, and microservices communication. It plays a vital role in enabling loosely coupled, efficient, and responsive software solutions in today's complex and interconnected computing landscape. Notifications are short messages or alerts deliverable to a user or system to convey important information and updates. They serve various purposes such as informing users about new messages, events, or application changes, enhancing user engagement, and providing timely reminders. Notifications are widely employed in mobile application, software, and the social media, email, and other digital platforms. They play a crucial role in keeping users informed and engaged by delivering real-time updates and uploading actions. So, effective notification systems can efficiently improve user experience, increase user retention, and enable efficient communication in both personal and business contexts. Fourth one, stream processing is a data processing paradigm that focuses on handling and analyzing data in motion as opposed to batch processing which deals with static data. In stream processing, data is continuously ingestion and proceed and analyzed in real time as it flows through the system. This enables organizations to gain immediate insights, detect anomalies, and respond to events they occur. So, stream processing is invaluable in various applications, including real time analytics, fraud detection, monitoring, and alerting. Technologies like Apache Kafka Streams and Apache Flink can commonly used for stream processing, providing tools to build robust, low latency, and scalable data processing pipelines. Kafka is mainly used in the real-time data pipelines, in which Kafka is often used as a central hub for collecting data from multiple sources. It can act as a buffer between services that produce and consume data. For example, you may have a service that collects data from numerous sensors and write that data of Kafka. Then you can have other services that consume that data from Kafka and perform analytics or operations on the data or store the data in a database. It is also used as the central hub for streaming data in a microservices architecture. And the last one is processing big data. Another everyday use of Kafka is to store high volume data and process it. Kafka can be used to process big data in batch or streaming mode. For example, you can use Kafka to process log files from the multiple services and to store the processed data in a database or such index. Kafka is a distributed streaming platform in which it is the backbone of real-time data streaming and event-driven processing. It establishes a reliable and scalable framework with producers, brokers, topic and the consumers, enabling high throughput data flow. The concept of topics and partitions enhances parallelism and fault tolerance. So Kafka distributed nature ensures robust of data replication. Importantly, it decouples data sources from consumers, providing the flexibility required for diverse applications. As a fundamental component of modern data-driven systems, Kafka architecture design empowers organizations to harness the power of real-time data processing and analytics. So its more four core components are producers, topics, brokers, and consumers. So what is the Kafka producers? Kafka producers are the components responsible for publishing data to Kafka topics. They play a crucial role in real-time data streamings. Producers format and send data which can include logs, events, or messages to specific topics, creating a stream of information. Kafka's reliability and fault tolerance mechanism ensure that data sent by producers is safely delivered to Kafka clusters, making it a vital component for collecting and distributing data within the Kafka ecosystem. Producers can be implemented in various programming languages and frameworks, allowing versatility in data source integration. Kafka topic serves a logical channel for organizing and categorizing data streams. They allow producers to publish data in which then distributed to consumers. Topics are the further divided into partitions which enable parallel processing and scalability. Each partition is replicated across Kafka brokers, ensuring data reliability and fault tolerance. So the topic are the fundamental concept in Kafka, allowing data to be categorized and efficiently distributed to consumers, making them a crucial component in building robust real-time data processing pipelines and event-driven architectures. Kafka brokers are the fundamental components within the Apache Kafka architecture. They serve as the core data storage and processing units. Brokers receive data from producers, store it in a distributed immaterial logs and serve it to the consumers. These logs are divided into partitions of parallelism, allowing high throughput data processing. This distributed and scalable design makes Kafka brokers the workhorses of real-time data streaming and event-driven applications. Consumers are the applications that read data from Kafka topics. They are essential components within the Kafka ecosystem. They subscribe to specific topics and consume data from them in real time. These consumers play a vital role in a distributed system. They can be a part of consumer groups allowing parallel data processing. Kafka consumers are adaptable and can be tolerated to meet various use cases such as real-time analytics and event-driven applications. Their flexibility and scalability make them vital for efficiently processing and acting upon the continuous stream of data provided by Kafka producers. Producers can produce data directly to consumers and that work for simple applications where data doesn't change. More complex applications, when you need to transform the data, you need to use the Streams API from the sophisticated stream processing. The Streams API leverages the producers and the consumers APIs to consume real-time data from a topics, analyze it, aggregate and transform it as a needed in real time to produce the resulting transform streams to a topic. The Streams API is the powerful feature of Kafka that enables you to develop specialized systems and complex streaming applications. The Connector API enables you to write connectors which are usable producers and consumers that are simplify and automate the integrate work. Whenever you need to integrate the same data sources like MongoDB and other databases, you can use these pre-built connectors API to get your data source into the Kafka cluster. Is numerous applications. The following three applications are most widely used. So first is the using Kafka big data function as a data source. So Kafka's architecture, including producers, brokers, topics and the consumer, ensure that the large volume of data can be reliably and durably transmitted to these processing engines. Producers can be connected to diverse data generators, publish data to Kafka topics. Kafka brokers distributed these data to consumers, including big data processing clusters, which can scale horizontally to handle massive workloads. This real-time data flow from the Kafka to big data platforms enables organizations to process, analyze, and derive insights from data as it arrives, following or the quickly decision making and faster responses to events. It process the valuable for the use case like real-time analytics, machine learning, and complex event processing. Kafka is a powerful tool for streaming big data in real time, making it an ideal source for big data processing. As is a distributed streaming platform, Kafka enables the efficient ingestion and transportation of vast amount of data from various sources to big data processing frameworks like Apache Hadoop, Apache Spark, and Apache Flink. Application of the Kafka big data function is the data processor. So Kafka plays a vital role in the realm of the big data as a powerful data processor and the conduct of the real-time data streaming. Kafka acts as a certain and the central nervous system facilitating the injection, processing and distribution of vast amount of data across a variety of big data applications. First and foremost, Kafka is a robust and the data injection mechanism. It allows seamless collection of structured and unstructured data from a magnitude of the sources, including IoT devices, web applications, and databases. The data is integrated and the ingest of a data topics and acting as a data streams. Kafka's role, a data processor, is highlighted through its ability to process these data streams in real time. Data can be enriched, transformed, and analyzed as it flows through Kafka. Stream processing libraries like Kafka Streams and Apache Flink can be used to perform complex analytics, aggregations, and filtering operations directly within Kafka. In big data landscape, Kafka serves a crucial link between various data storage and processing techniques. Data can be efficiently transported from the Kafka to data lakes, databases, and distributed processing frameworks such as Hadoop, Apache Spark. This seamless integration allows organizations to build comprehensive big data pipelines that support real-time analytics and batch processing. Third, but not the least, using Kafka Big Data function to resync nodes in big data cluster such as Hadoop and Spark cluster using Apache Kafka can be a valuable approach to maintain data consistency and fault tolerance. Hence, there are the big environment and maintaining data consistency and enduring and ensuring that the data reliability and availability will be crucial. Apache Kafka, with its distributed and fault-tolerant architecture, can be play a vital role in resyncing nodes within a cluster. First, data replication. Second, consumers for the read sync. Third, continuous data integration. Fourth, data transformation. Fifth, checkpointing, and sixth, scalability. So the another important one is you can configure Kafka to retain records based on a time limits, size based limits, and the compression by leveraging Kafka Apache For a resyncing nodes, a big data cluster can ensure that all nodes remain synchronized, data consistency is maintained, and the clusters all over fault tolerance is enhanced. This approach provides a robust and the real-time solution for keeping big data clusters up to the date and the latest data changes. Apache Kafka offers several advantages that make that powerful and versatile tool for a real-time data streaming and event-driven architecture. One of its primary benefits is the ability to handle high throughput data in a fault-tolerant and scalable manner. Kafka's architecture, composed of producers, brokers, and consumers, allows for the efficient ingestion, storage, and retrieval of data. This makes it ideal for use cases. There are several architecture advantages and some of our scalability. This Kafka scalability is one of its defining features. It can effortlessly handle growing workloads by distributing data across multiple brokers, ensuring high throughput and fault tolerance. This distributed architecture allows for easy horizontal scaling, making it simple to add more brokers and partitions to accommodate increased data volume and processing demands. As the data needs expand, Kafka's ability to scale with minimal disruption and it remains a robust and reliable choice for handling tools and the vast amount of data in real time, supporting the evolving requirements of modern data intensive applications. Apache Kafka excels in high performance data streaming. It can handle enormous data volumes with low latency, making it ideal for real time applications. Kafka's distributed architecture and performance employ enable parallel data processing, while replication ensures the data reliability and fault tolerance. Its lightweight data design and minimizes overhead. Additionally, Kafka support for various programming languages and its ecosystem of data connectors and stream processing tools make it adaptable for a diverse data cases. These features combined with efficient data compression and batching contribute of data and exceptional performance. Top choice of industry relying on real-time high-throughput data streams like finance, social media, and IoT. Kafka ensures fault tolerance through data replication. Each piece of data is replicated across multiple Kafka brokers, making it highly resistant to hardware failures, ensuring data availability and system reliability. In conclusion, Apache Kafka stands a fundamental and foundational pillar in the realm of the real-time data streaming and event-driven architecture. It distributed, fault-tolerant design facilitates high-throughput data ingestion, storage, and retrieval. Kafka's architecture, comprising producers, brokers, and consumers, enabled efficient, scalable, and reliable data processing. It introduces the concept of topic and partitions, enhancing parallelism and reliance. Kafka's decoupled nature allows for flexibility and the independent data processing, make it adaptable for a wide range of use cases from log aggregation to real-time analytics and event sourcing. Moreover, Kafka Pro support for data application ensures data durability and consistency, and its low latency performance make it independent and the timely deliverable. It the With its ecosystem of connectors and integration with various technologies, Kafka has become a linchpin of the modern data driven systems. In essence, Data Kafka and Apache empowers organizations to harness the potential of the real time data, enabling them to react swiftly to changing conditions, extract valuable insights, and build robust event driven applications, making it a cornerstone of contemporary data processing analytics. Thank you.